My name is Gray Kane. I'm the director of the Gertrude C. Ford Center for Teaching and Learning here at Delta State. I'm going to talk about learning only from a physiological standpoint and then address its implications for course design. The most common paradigm for discussing learning is Bloom's taxonomy. Now, Bloom's taxonomy is often presented as a pyramid because each level on the pyramid informs the skills above it. So in order to be able to comprehend something, you have to have knowledge about it. You need to use your memory. In order to be able to apply something, you need to know it and comprehend it. In order to analyze something, which is take a whole and divide it into its component parts and relate the parts back to each other in the whole, you have to know what it is, comprehend it, and be able to apply it. And it works this way all the way up to evaluation. As useful as Bloom's taxonomy is, we're going to look at learning as a physiological process. Most of us have heard of neural networks. We can think of a neural network as a cellular net draped over the brain. Many of those cells, also called neurons, are actual concepts. In other words, knowledge are cells interconnected in a network of meaning. And learning new knowledge physiologically requires that we connect it with prior understandings. When students lack the adequate background knowledge or skills to connect new knowledge to, in other words, they lack the appropriate concept neurons to connect new cells to, they have a physiological impediment to the learning process. It's not that they can't learn the new content, but they'll likely have to learn it through analogies. One biologist told me she teaches cellular division by relating it to Walmart. So the students, at least temporarily, can retain and recall the new knowledge via the concept neurons in their brains associated with Walmart. If that were the only way the students could retain or retrieve the content, that would be very limiting. So you can see the importance of diversifying the ways students relate and use information. Here's our first key takeaway. Helping students diversely interconnect knowledge improves the accessibility and usefulness of that knowledge. Now, repetition plays an important role in all this. Repetition and rest, and we'll get into more details about rest in a minute, but repetition and rest strengthen the connectivity and flow between concept neurons. They generate an electrically insulating membrane called myelin around any pattern uses of concept neurons. That membrane allows for rapid-fire uses of knowledge. However, a course design that doesn't routinely introduce variation into the repetition of concepts or information, and not just variation in which concepts relate to which, but also the ways by which the students can access the same content and demonstrate competency, any course that doesn't vary the students' repetitive practices will discourage the rapid-fire usefulness of knowledge in diverse contexts. We've all experienced the inability to discuss something new we've learned. Perhaps we've read and reread a difficult concept until we can finally say, I've got it, it makes sense, I finally got it. But someone else asks us to explain it and we're at a loss. One reason we can't explain it is we haven't yet connected it to the parts of the brain associated with speech. Similarly, we can know something without being able to do it because it's not yet interconnected with the motor cortex. Different parts of the brain perform different functions. When we structurally encourage students to access the same course content using different parts of the brain, reading about it, hearing a lecture about it, discussing it, performing tasks with it, we strengthen the connectivity of those concept neurons. We actually improve the accessibility and usefulness of new knowledge. Here's our second key takeaway. Repeating and varying the ways students work with the same knowledge builds their capacities for using it. Now, rest is important, not just because the electrical insulations have to form, but also sleep plays an essential role in the creation of long-term knowledge. New knowledge, or cells, generate in a small part of the brain called the hippocampus. During the first 6 hours of sleep, they migrate to the prefrontal cortex, from where they can then integrate into the activated parts of the neural network. The last hour and a half of a 7.5-hour sleep cycle clears the hippocampus in preparation for the next day's learning. People who don't get enough rest not only have trouble integrating new knowledge, but they also experience difficulty with learning something new. This is why a student can stay up all night cramming, satisfactorily pass a test, and retain none of that knowledge for the rest of the course, let alone the next course in the sequence. Also, they'll be completely useless in any other course they attend that day. They won't be able to learn anything. How sleep impacts learning also has implications for course design. Most of us design our courses in modules, with the topics corresponding more or less with how they're organized in the textbook. But that design rarely provides sufficient opportunities for students to return to the same topic after rest. Instead, we should be thinking about how to design the course so students periodically return to each topic and more diversely integrate it with other knowledge or skills throughout the semester. That way, sleep can play an active role in the course. The term for this type of course structure is interleaved practice. Here's our third key takeaway. Spacing and repeating students' practice of the same knowledge over the course of the semester improves their long-term memories of that knowledge and the likelihood of their retaining it to the next course in the sequence. Here are a couple other aspects of memory to consider. We've all attended a conference presentation with 15 or more bullet points per slide. As attendees, we likely had problems processing all of the information or retaining it throughout the presentation. That's because working memory can hold only 5 to 9 bits of information at any given time. In order to retain more, people have to chunk information into themes, groups, or categories. When we're giving a lecture or presentation, we can help people retain that knowledge by organizing the presentation into highly visible categories, and by presenting no more than 5 bullet points on a slide. We may also need to provide opportunities for people to mentally process the organizational structure. We should also remember that students will have trouble recalling knowledge differently than how they chunked it. This is true not only of new learners, but also experts. Many experts, particularly newly minted PhDs, have difficulty discussing their work without technical jargon. They can't talk about their work on a sophomore level because they haven't diversely integrated their experience with layman's terms. They didn't chunk it that way. Here are 3 takeaways from this presentation. Helping students diversely interconnect knowledge improves the accessibility and usefulness of that knowledge. Repeating and varying the ways students work with the same knowledge builds their capacities for using it. Spacing and repeating students' practice of the same knowledge over the course of the semester, not just over the course of a day or a week or 3 weeks even, improves their long-term memories of it and the likelihood of their retaining it to the next course in the sequence. I hope you found this presentation to be useful. For more information about this topic, its bibliography, or to schedule an individual teaching consultation, please contact me through the Center for Teaching and Learning's website. Thank you.